Hello, Miss Welch here. Okay, so we're going to do day one of all our calculus applications. So today we're going to do tangents and normals. Yeah. And remember that the derivative of a point is this at a point is basically the slope of the function or the slope of the tangent of the function. And remember what a tangent is, that a tangent touches the curve at a certain point, only at one point. Whoops. So when you find the derivative, you find the slope of this thing. And then a normal is a line that runs perpendicular to it. Okay. Also important to remember, the relationship between the tangents is negative reciprocal. Yeah. So if this is m1 and then this is our m2, then m1 is always, it's a negative reciprocal of the other one. Okay. So for example, if the slope of a tangent is 3, so I'm just going to fix my equal sign because they're not equal, they're perpendicular. Then the perpendicular slope of the normal will be 1/3. Or the opposite, maybe they give you the slope of the normal. That means that the slope of the tangent is, you can pause it, keep it in suspense, try it on your own, is going to be -3/4, okay? So that's the relationships between the tangent and the normal. Okay, so going to work with a little bit of context here. So there's a wide road, whoosh, passing a lake, and then they give us the function, and then there's a fire station that is right here to save time during emergencies and so on. Okay, but you should always read all the information and the context. Use your graphing calculator to find the slope at -1. So remember, when it's a specific point, even if they don't tell you to use your calculator, please do not attempt to derive this. You will fail. Sorry to be harsh, but that's the truth. Okay, anyway, you don't know how to derive this, okay? Yeah, so I've already put the function in, and then we're going to graph it. This isn't great. What I would do is maybe look at my y's. They're huge. Why don't I try something like, I don't know, -50 to 50. And then, okay, that looks a little bit more like the sketch. So what we're going to go is, remember, we're going to go to the x value. We're going to go to -1, and then we're going to go to function, and then we're going to go to slope. Okay, so remember, as soon as you see the derivative, that's the slope of the function. And so it's going to be -8. So again, go to the x and then go to function. Slope is your friend. Okay, find the equation of the line normal at point A, which can be used to model a new bridge. Okay, so this is the normal line. I'm not going to, you shouldn't extend it, but just to kind of give you the idea, there it is, perpendicular. Okay, well, the first step, of course, is to actually, you know what we're going to do? We're going to use, yeah, the first step is to find the slope. So remember what this is. When you find the derivative, it's the slope of the tangent, okay? So therefore, the slope of the normal is going to be negative reciprocal of that, is going to be 1/8, okay? And so now I'm actually going to use the point slope form. I know you don't all love it, but the nice thing with that is that it allows you to be lazy. Who doesn't want to be lazy? We're at this point, so this is our x, this is our y. And so this is going to be 1/8, and this is going to be -1, so it's going to be plus. So the nice thing with this is that you're done, as opposed to if you're hanging on to your mx plus b, then you have to do all of this work, okay? And here you just don't. Okay. Hence determine the length of the new bridge. All right, so I'm just going to delete this, and we'll need space for C. So let's look. So what we need is we need the length. Okay, we need this. Oh, brother. So the first thing we're going to need is we're going to need point B. Okay, how do we find point B? Well, we have the function, and what we can do is we can just graph this line. Okay, this is just slightly sticky. And by the way, if you want to do your mx plus b and then see if you get the right answer. You can't put this in the calculator because you do need to isolate for y. So just add 6 to both sides, and then you have 1/8 of x plus 1, and then you have 6. The fact that it's in a messy form, we don't care. We just need to get the line in there, okay? This is the easiest way for you to pick up marks in the least work possible in a minimum amount of time. Okay, so just throw it in there. That's why it's important to have a window. Be careful because I think it actually crosses 3 times. So don't look for this one. There's this one. If I go to this one, you can guess what it's going to be, right? It's going to be the -1 and 6. So we actually need this one. So we're going to go to intersection of this one. Yuck. God. And I'm actually not going to round because, like, why? Remember, we only use rounding when the number goes on and on and on. If it finishes, just write out the whole number. You look fancy. So now that we know that this is point B, it's not a big drama to find the distance between them by just using the distance formula. So we're going to do x2 minus x1, and then y2 minus y1. Okay, and then again, practice, sub it in. Watch me making mistakes. So this is going to be minus 1. Be careful. And then 740 minus 6 squared, all under the big mother over root. Okay. So minus 5.0208 plus 1 plus 5.497. Was this 4 or 9? Oh, 4. And then minus 6 squared. Yay! Okay. Oh, I see what I did there. Sorry. The whole thing should have been squared, not this. Oh, God, Miss Walsh, what are you doing? Okay, that sounds much better. It's okay. I wanted you to see what to do. If you get an error, don't panic and just go back and figure it out, okay? So this is the approximate, what is this, meters? Nobody knows, nobody cares. This is your distance for C, okay? There you go. So now let's do this one. Okay, this is a little bit more challenging. The gradient of the normal to some curve at this point is that. Calculate A and B. Oh, brother. Okay, so first of all, ax squared plus b minus 10. This is some sort of a quadratic. I may not be drawing it perfectly, but who cares? Okay, so a 2 and 4. I'm just going to put that here. Then we know that the slope of the normal is -1/3. Oh man, how do we start this? Okay, well, the first thing, I mean, what could you possibly do? I don't know. I guess the first thing we could do is just like sub in a point. Also, if you see that there's 2 unknowns, most likely, unless there's some other information being given, you're going to need 2 equations. So our first equation is like, let's just sub this in, okay? So this is going to be y, then this is going to be squared plus b times 2 minus 10. We are going to use linear solver eventually, so I'm just going to clean this up and add 10 to both sides, okay? Just to get it into that correct linear solver form. And so we're going to have 14 is equal to 4a plus 2b. What to do? Well, okay, the normal in itself is like not that useful. There's not that much stuff you can do with it. But if you have the slope of a tangent, that would be cool. So we can totally get this. So the slope of a tangent is going to be not negative but positive, and not 1/3 but 3/1, which is 3. And now, guess what? Guess what? That means that we know that the derivative of y is equal to 3. So then our other equation we're going to derive, okay? So then y prime is equal to 2ax plus b. This is just a constant, don't let it panic you. And now you know that it's going to be 3 is equal to 2a. Now don't forget where this is all happening. It's happening at 2. So your x is 2. The fact that the y, you don't care, because you don't care how high this is happening, okay? Let's just clean it up. And so what we're going to have is we're going to have 3 is equal to 4a plus b. And now you could do it with algebra, but why? We be lazy, okay? So be careful. So first you're going to put in the 4, then you're going to put in the 2, then you're going to put in 14, and then 4, 1, 3, and there you go. So this is your x, this is your y, which stands in our context for a is equal to -2, b is equal to 11, okay? You're done. Don't forget that you can check. Let's check with like a really cool color. So here's how you check. Let's just check if the function that we ended up with actually matches the information that we were given. So -2x squared plus 11x minus 10. Okay, I'm going to get rid of this. All right, so so first of all, if you go to num, check it out, it does indeed pass through this, okay? And then the other thing that you can check, you can't check the normal, but what you can do is you can go to 2 and check that the slope of the tangent should be 3, right? Ready? Function, drum roll, dum-da-da-dum. Why are we so smart? Okay, that's it. Good luck with the homework.